Greetings and welcome, friends. This is Mr. Waddy here. We're taking a look at section 3.7. We are graphing absolute value functions. Oh my goodness. Wow. This is crazy. We've never graphed one of these things before. Well, some of my students in real life have. But here we go. An absolute value graph. If I have y equals x or f of x equals x, that would have been a line with a slope of 1 and a y-intercept of 0, but absolute values like there can never be negatives, and it would then just ricochet all of these negative y values up into positive y values. So that's all the absolute value ends up doing, and you end up having like this little ricochet right off the vertex here, which is the name of that change in direction, your valley bottom or your mountain peak, if it's an upside down absolute value graph. So an absolute value function is a function that contains an absolute value inside. That makes sense. That just makes sense, right? Good job naming that, mathematicians. Good job. Let's see. The parent absolute value function is f of x equals the absolute value of x. The graph is V-shaped, so I like comparing V and value, so I remember those things, right? V. There we go. V-shaped and symmetric about the y-axis. What does that mean? That means that if I was to mirror this side, it gets mirrored over there. All right? So if I go up 1, over 1, up 1, over 1, on this side, I'm going up 1, backwards 1, up 1, backwards 1, and it's mirroring every move I make over there gets mirrored over on that side. Whoop. Well, that's fine. I undoed a little too far. The vertex is the point where the graph changes direction, and the vertex of the graph happens to be the origin when we're talking about the parent function. Now, in terms of domain and range, guys, we haven't talked about domain and range in a while. This is so exciting. Domain are the possible x values. Notice if I was to represent all possible x values, it's everything. It's everything, right? If I was to smoosh this down here and this down there and this down there, right? All possible x values end up getting hit forever because this just goes forever this way, and then I could smoosh it down to the x-axis. So that the domain of this function is all real numbers, everything. However, the range, notice this, that crazy range. If I was to smoosh it to the y-axis, the values that I get only exist from 0 and up. I didn't get any negative numbers for the range, so the range would have been the set of all y such that y is greater than or equal to 0. Okay, so the range is actually partially interesting here. It's not like a line where just everything is true for the domain and range. So let's see, let's do our first example here. This will be good. It's gonna be great. Doing the graphs of things. Okay, here we go. So here we go, example 1. Let's graph these. Let's see, did I talk about horizontal and vertical shifts yet? No. Oh, but they're kind of having us discover them. I see what they're doing. They're doing one of those classic moves. Classic move, right? Where we give you the equation, and if we don't know how to graph something, do you guys remember slope-intercept form? What did we do back then before we knew? How did we graph lines before I knew about slope-intercept form? Does anyone remember? We made a table of values. And so, like, if you don't know how to graph something, that's perfectly fine. You can make a table of values, and it'll work out just grand. Just grand. Lovely. So we'll make a quick table of values for each of these, and then once we recognize some patterns, we'll be able to graph using transformations. Transformations. So let's see. Let's think about x and g of x. I'll make a table of values, and then we'll graph them. So when you're picking a table of values, you should try some negative numbers, you should try some positive numbers, and you should always try 0, because 0 is everybody's friend. Let's see, so -2, -1, 0, 1, and 2. Did I give you guys graphs on this? I hope I did. I did! You're welcome, friends. So let's see. Well, let's start with the easy one, 0. The absolute value of 0 is 0. and then I add 3 to it, and I get 3 as my output. So I'll plot that point, 0, 3, right there. Lovely. The absolute value of 1. What's the absolute value of 1? If I plugged in 1 up here. That's 1. And what's 1 plus 3? Not a trick question. 4. Nice. Audience participation. So 1 comma 4. So let's plot the point. Over 1, up 4. There's that point. Okay, this is interesting. Look, so it's just going to be a line, right? Wrong, because there's absolute value. There's going to be a V in here somewhere. Let's see. Let's plug in 2. The absolute value of 2 is still 2. Absolute value didn't do anything. And 2 plus 3 is 5. Okay, so over 2 and up 5. Good times. Now let's try one of these negative numbers here. If I plug in -1 for x, what's the absolute value of -1? How far is -1 from 0? How far is -1 from 0? Or it's 1 unit away, right? Or if I ask, what's the absolute value of -1? It's +1. And then what is 1 plus 3? 4. We already figured that out. We did 1 plus 3 earlier. Wow, this is interesting. So -1 and up 4 would be a point right here. Yeah. And let's see, let's plug in -2. What's the absolute value of -2? Well, that's +2, and 2 plus 3 is 5. I feel like I've done this before. -2 and 5. Hey, look at this. What do you guys notice about these numbers? What do you guys notice? It's kind of like a mirror almost. Like in one direction, it's 3, 4, 5. The other, then if I go this way, it's 3, 4, 5. So it's kind of interesting the way that works out. So let's see. Let me plot some points. Draw my graph. So it looks like this is a V, which it is. Something like. I'm not on the right. There we go. There we go. So this is an absolute value graph like so. What do you know? And it goes forever this way and forever that way. Right? So there's my graph. How did this compare to the parent function? How did this compare to this graph? That graph and this graph. Where's the V? Where's the vertex? All right, this vertex was here at 0, 3, and the other one's vertex was at 0, 0. It looks like this one is just 3 units higher, right? It looks like it was shifted up 3 units. Like a vertical shift, maybe? Mysterious. Let's see, they also asked us to figure out the domain and range. The domain is, well, everything. So you could just say all real nombres. And the range, I like this range. This is a cool range. Yeah. Not all of them. Not all of them. So we will, we'll eventually get some graphs that aren't just all real numbers for the domain. For algebra 1, a vertical line is an example where like your domain would only be the values that made that line true, and then it wasn't true for everything else. Later on in algebra 2, if you're graphing a square root function, or in pre-calculus, if you're graphing like circles and ellipses and hyperbolas, you won't have that be the case. Or sideways parabolas. Don't worry, those are just all crazy words right now. You don't have to be afraid. But yes, for right now, most of the time, our graph's domain will just be all real numbers. But notice for the range, it only exists from 3 and up. So my range is the set of all y such that y is greater than or equal to 3 times. All right? So I could have graphed this using a table of values, but eventually we'll just be able to do this using transformations And I would have been like, well, this was just shifted up 3. Okay, I'm going to graph this next one a little quicker, okay, friends? Here's x, and here's x, m of x. So let's see, let's pick the same points, -2, -1, 0, 1, and 2. Now here, the -2 is inside the absolute value. The call is coming from inside the house. And so the absolute value of x -2, all inside, right? Or the absolute value of the difference of x and 2, maybe I could say that. Let's plug in some number. What happens when I plug in 0? What's 0 minus 2? Well, that's -2. And then what is the absolute value of -2? +2. So 0, 2 is on my graph. Now that does not mean that that's my vertex. Okay, my vertex is where the graph is going to change direction, so be careful. Plug in 1. 1 minus 2 is -1, and the absolute value of -1 is +1. Okay, so there's 1, 1. All right, looks like it's still going downhill here. Let's plug in 2. What's 2 minus 2? 0, and the absolute value of 0 is still 0, so 2, 0. Boy, this is weird. Huh. Let's plug in -1. -1 minus 2 is -3, and the absolute value of -3 is +3. All right, so notice I'm just kind of doing the, +3. I'm just doing like this table of values a little bit in our head. That's scrap work that I don't think you guys have to show out that way. We would just write the table. So let's see, -1 and up 3. Guys, I don't know where my vertex is. Like, it hasn't changed direction yet. What do you guys think? Well, let's see. We'll do -2. We'll see what happens. -2 minus 2 is -4. And the absolute value of -4 is +4. So -2 and then up 4. Where do you guys think? I still don't know where my vertex is. Should I try one more point? Let's plug in 3. Let's just see what happens if I plug in 3. All right, 3 minus 2. 3 minus 2 is regular 1, and the absolute value of regular 1 is +1. So 3, 1. So over 3 and up 1. Aha! I found my vertex. Found it. In your face, vertex. You aren't gonna hide from me. Oh, no, I wasn't gonna tell you. Please. Please. All right, so it looks like my absolute value graph is gonna be something of the sort like so. Right? And so I made a table of values. It looks like this was a horizontal shift right in the positive direction by 2, which is kind of what we were predicting earlier. So yeah, so horizontal transformation. What's the domain here? It's just going to be all real numbers. Actually, guys, yeah, we'll write it out. All real numbers. And anyone have an idea of what the range is? What are the possible y values? Set of all y such that, let's see, what's the smallest y value that we have? Yeah, 0, and then it's everything above that. So I would describe that as y is greater than or equal to 0, right? Okay. Where's my mouse at? Here we go, mouse. My mouse is all mousy. Guys, I brutally murdered a mouse last night. I set a trap on my stove. Whew. It's all right. It was him or me. Well, not really, but either way, it was him. No doubt about that. I guess if he gave me a disease, then it would have been me. Like a disease that could have killed me. Like if he had the Black Death, You know, that wouldn't have been good. Yeah. All right, so here we go. Oh, my apologies. Here, right back at you. Let's see. I don't know. I wonder if I should pick up the pace here. I think you guys would get these table of value things. You guys don't want to do more table of value graphs, right? You want me to start teaching you how to do transformations? Yeah, I think I'm gonna do that. I think so. I'm gonna transform. It's gonna be amazing. Ooh, wow. They jump right in with these transformations though. Okay, maybe that's what we'll do. We'll graph doing transformations on this. I'm expecting this to be a vertical stretch. By 2. All right. So let's see. The parent function would have looked like this. So here's what the parent function looks like. Just the classic V. The Mighty Ducks right there. And a vertical stretch by 2. What that ends up doing, let's see, what's a good color? I'll use the blue. I would take all of these points. 0 multiplied by 2 is still 0. 1 multiplied by 2 is 2. 2 multiplied by 2 is 4. 3 multiplied by 2 is 6. I'm just taking all of the y coordinates and doubling them. 4 multiplied by 2 is 8, right? And here we go. Same over here. Do-do-do, 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 do-do-do. All right, so this ends up being a steeper parabola. And actually, in terms of slope, which you can't imagine this sorry, I just said parabola. Oh my goodness, a steeper absolute value V graph. And if you think about slope, right, you could imagine the slope, quote unquote, is 2 for this side and -2 for the other side. Maybe I'll even write plus or minus 2 for the slope. So this is down 2 over 1, down 2 over 1, where this one was up 2 over 1, up 2 over 1. And that's what we end up getting. All right, this one over here, multiplying by 1/2 would be a vertical smoosh. All right, by 1/2. But then what about this negative? What do you think the negative does? It will reflect it over, let's see, it's on the outside of the absolute value, so it's going to change the y values. So that means a positive y value will now be negative. So it's reflecting it over the x-axis. All right, let's see if we can put all this together here. So let me graph my regular parent function. Oh, that's not quite right. That'll do. Right there, and right there. And I'll do this in steps. So let's do a vertical smoosh by 1/2. So let's see, I'm gonna pick points that are divisible by 2. So the 0, the vertex, 0, 0, 1/2 of 0 is still 0. Here's 2, a y coordinate of 2, 1/2 of 2 is 1. Notice I didn't pick 1 because, yes, I could have plotted at 1/2, but let's just pick nice numbers. Let's see, 4 is divisible by 2. What's 4 divided by 2? Friends, 4 divided by 2. My apologies. Is 2. Yeah. What about 6? 6 divided by 2. Guys are quiet. Tyler, what do you think? 6 divided by 2 is going to be 3. All right. And so if this exists over here, it's also mirrored over there. So here's this point would be right there. This point would be right there. And then the next point right there. Let me draw. So this is not my answer yet. This is just like a half step that I'm doing. Let's see. That's not the right one. That's where I need it. Okay, so this is a vertical smoosh where it's now half the slope. But now I still have to, so that's step 1 that I did. Now I still have to reflect it. So reflect over the x-axis. Let's see, reflect 0 over the x-axis, that's still at 0. Reflect 1 over the x-axis, that's going to now be at -1. Reflect 2 over the x-axis, that'll be at -2. Right, and I just mirror this. Mirror, mirror on the wall, right? And my final result is gonna be something like this. What's your question? Yeah, absolutely. Right, so graphing in terms of transformations is much easier. Much easier. And you can have transformations with all sorts of things. All sorts of things happening simultaneously. Here, if you got just the first one done, I'll let you go back and get the next one after. We'll get some more examples. Don't you worry. Don't you worry. Let's see. So vertex form of an absolute value function. So if I think about this as kind of being my form, this will affect stretch or smoosh, right? Also reflections. Okay. The H will be horizontal. Shifts. And the K will affect vertical shifts. All right. And so if I have, just like we have slope-intercept form of the equation of a line, here's vertex form for an absolute value function, where this is going to kind of determine my slope almost, and then my starting point is going to be at h comma k is my starting point. The vertex of the graph is going to be at h comma k. So instead of having a slope and a y-intercept, I'm going to have a vertex and then kind of my slope, I guess, if you think about it that way. All right, so this is going to be good. Let me tell you, this is going to be good. All right, so let's see. Let me, okay, why does it do that? Stop ghosting me, computer, when I copy and paste. All right, so we're going to graph, thinking about these in terms of vertex form. Vertex form. So let's see, I've got a graph. Here's example 3. Let's see if I can figure this out. So for f of x, yeah. And yeah, we'll be looking at this. So for f of x, notice that the value of a in this equation is a 1 there, like so. All right, so I'm not expecting that equation to have had a vertical stretch or smoosh. What's the value of h? Let's see. Let me write this down. So a equals 1. h. Now h, it's always minus h right here. So what would this h have been if that's showing up to be a plus 2? It's going to be the opposite of that number. Okay, so h is going to be negative 2. All right, opposite. And the k is going to equal negative 3. Negative 3. Man, these are kind of weird problems the book's choosing to do in the order they're doing it in. Not the most impressed. So for this equation, I figured out A, I figured out H, and I figured out K. I'm going to start at H comma K. So step 1, plot H comma K. So where is, so that's going to be negative 2, negative 3. So from the origin, left 2 and down 3. And this is going to be my vertex. And now the slope, so to speak, is 1. And then find more points using, I'll just call it slopes of plus or minus A. So this is going to be up 1 over 1, plot a point. Up 1 over 1, plot a point. Up 1 over 1, up 1 over 1. And it also has a negative slope in the other direction. So I'm going to go up 1, backwards 1, up 1, backwards 1, up 1, backwards 1. And if I want to graph that, that is what I would end up getting. Now, I'd get the same graph if I did do a table of values, which is what the book was hoping you would do on this problem. But I'm just kind of like, meh, we'll do this. Like so. And notice that in terms of the parent function, this was the same as a horizontal shift left 2 and a vertical shift down 3, right, which are completely related to these numbers here. All right, so horizontal shifts by that amount. Let's see, maybe I can. This is what I think I'll do. I want to show you the graph. Boy, I'm at a crossroads. I've got a couple minutes. Now let's see. If I have a number in front of the x in terms of transformations, that's the only difference between these two. We're expecting that to be a horizontal smoosh. Okay, right? We talked about that before. Here we go. My students already saw this, my in real life ones, that when the number in front of the x, still inside the absolute value, is bigger than 1, it's a horizontal smoosh, and when it's less than 1 and bigger than 0, it's a horizontal stretch. So that's what I'm expecting that to do. So I would expect this to be the graph that is a horizontal smoosh by a factor of 1/2. But it looks like I'm just about out of time. We might have to finish this lesson on Monday. I think that's what we'll do. All right. Well, thank you for watching, Internet friends. You all have yourself a great day.